One other question that came up was when you have numbers like this, 2 plus 2 plus 2 plus 2 plus 2 plus 2, all divided by 2 plus 2. But of course you can work this out. 2, 4, 6, 8, 10, 12. That's the same as 12 divided by 2 plus 2, which is 4, which we know is 3. But another way of working this out is just to change it into times. We've got 2. How many lots of 2 do we have up here? 1, 2, 3, 4, 5, 6. We've got 6 lots of 2's on the top, and we've got 2 lots of 2 on the bottom. 2 divided by 2 cancels, and 6 divided by 2 gives us the answer 3 directly. So it saves a little bit of time, and we get simpler terms. The same thing happens if we were to have something like this. What about if we had A times A times A times A times A times A, all divided by A times A? Okay, well, when we've got multiplied, it's really easy, because what we've got here is how many powers of A do we have? A to the power 1, 2, 3, 4, 5, 6. We have A to the power 6 divided by A squared. And we know that whenever we have powers, we just subtract the powers. So when we're dividing, we can do this by doing A to the power of 6 minus 2. It's the same thing. When we've got powers, A to the 6 divided by A to the 2, we get the number of A's left over by A to the power of 6 minus 2, which is the same as A to the 4. Let's check if that's right. I can cancel one of these A's against one of those A's, and I can cancel one of these A's against one of these A's. How many powers of A do I have left? 1, 2, 3, 4. So I'd get equals A to the power 4 even here. But what happens if we don't have times? Because times and dividing is always easy, because then it's just to cancel. What happens if we instead have all of those A's added together? So if we had A plus A plus A plus A plus A plus A, all divided by A plus A. Let's make it an odd number of A's here. Okay. Well, we have to think, what does A plus A plus A, all of these number of A's mean? Well, it means we've got 1, 2, 3, 4, 5, 6, 7 lots of A's. So we have 7A on the top. And how many A's do we have on the bottom? 1 plus 1. We have 2 lots of A at the bottom. So A plus A is the same as the number 2A. We now have 1A divided by an A, cancels, and we get 7 divided by 2 equals 3.5. So the A's disappear when we are adding in this way. Let's see if that's actually right then. Is that going to happen? Well, we could split this up by A plus A here is 2A. So we get divided by 2 lots of A. And but then we get the same thing. We get 7A on the top and 7 lots of A on the top and 2A on the bottom. So the A's cancel, giving us 3.5. So understanding the difference between adding the A's here and that gives us 7A, whereas if we'd been multiplying these A's together, we'd have got A to the power of 7. Understanding the difference between adding the A's to give 7 A's and multiplying the A's, which would have given A to the power of 7, is super important concepts in maths. And you have to understand the difference. This top one would be saying like 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, 2, 4, 6, 7, all divided by 2 plus 2. Whereas this one would have been equivalent to multiplying 2 times 2 times 2 times 2. It would have been a totally different answer and a much larger one. 1, 4, 6, 7, divided by 2 times 2. We'll get very, very different answers whether we're adding the 2's together or whether we're multiplying the 2's together. And that's such an important concept to make sure you don't muddle up in maths.